This meeting is being recorded.
Problem 1 from Chapter 9 asks us to provide a systematic name for each of these following compounds. So if you recall with alkanes and alkenes, step 1 is always to find the longest carbon chain and identify the parent. So in the case with double and now triple bonds, the parent chain must contain the triple bond in this case. So let's take a look at molecule A here, and let's see what we find. So we have 1, 2, 3, 4, 5, 6 carbons in our longest carbon chain, and we only have 1 carbon chain, so we know that it must contain our triple bond here. And also notice that there are no substituents. So we have identified our parent, and that would be a hexyne, because there's 6 carbons in this chain. There's no substituent, so we don't have to name anything else. Besides, we have to provide a locant for the position of the triple bond, and that's always the lowest carbon that starts the triple bond. So we have between 3 and 4 here. So this will be 3-hexyne. Let's take a look at our second molecule here. So if you notice, this is almost the same as the first. We have 1, 2, 3, 4, 5, 6 carbons in our longest chain, and then we have 1 substituent here now. So we're going to name this very similarly. So we know that our parent is going to be a hexyne again. We know that it is a 3-hexyne. Because the placement of the triple bond is in the same spot right here. But now we have a methyl substituent, so this will become 2-methyl 3-hexyne. Next, we have molecule C here. So if we start numbering from this end over here, we would see 1, 2, 3, 4, 5 that are triple bond. This would be a 5-octene because there's 8 carbons in the total 8 total carbons in the longest chain. But we want this locant for our triple bond to be the lowest possible. Just like when we number our substituents, they have to be the lowest locants possible. So we're going to start numbering from this end here. So we have 1, 2, 3, 4, 5, 6, 7, 8 carbons in our parent chain. So this, as I mentioned, will be an octene. And now our locant for our triple bond, this will make this a 3-octene. And once again, there's no substituents, so this is it for this nomenclature. Let's take a look at D now. So the longest chain would be 1, 2, 3, and then no matter which way we go, we're going to have 4 carbons in our longest chain that contains our triple bond. So we have 2 methyl substituents that result on this carbon 3 here. And remember, our parent, our triple bond, must be prioritized as the lowest numbering. So that's why we're going to end up with a 1-butyne. And then we have to name these 2 substituents, these 2 methyl substituents on the carbon 3. So we would name them both with the locant 3, 3. And then we're going to have a dimethyl, I'll squeeze that in there, dash 1-butyne. So 3,3-dimethyl 1-butyne for compound D. And the last compound that we'll take a look at together, our longest carbon chain. So we're going to have to start here and count 1, 2, 3, 4, 5. And then we get to this crossroad here. So we could go down, and that will give us just 1, 2, 3 other carbons in our longest chain, or an octene. But if we go up here, notice that we have 6, 7, 8, and then we should have 9, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we end up with a nonine. So this will be 9, 8, 7, 6. So our parent in this case is nonine for a 9 membered carbon chain. And the triple bond is between carbons 1 and 2, so it's a 1 nonine. And how many substituents do we have? So we have a 3-carbon substituent down here, so that's a propyl group. We have a 1 carbon up here, that's a methyl substituent. So the way we would name this is that we have to alphabetize. So our methyl comes before our propyl. So we're going to have a 7-methyl dash 5-propyl, 1 nonine for molecule E here. And this is the first 5. There are 2 others that you can try on your own.